Time to continue with power of a point, part 2, which you're going to find is a little bit different from part 1, because this time it involves a point P outside of the circle. So power of a point, part 2, just says that PA squared is equal to PB times PC, which is also equal to PD times PE, where point A is tangent to the circle. And when we say A is tangent to the circle, what we're really saying is that the line PA only hits the circle at one point, at point A. So this one should be used whenever we have line segments and points outside of a circle. Now before we go on to our first problem, I just want to say something really important. Notice that it's PB times PC is equal to PD times PE. Notice how it is not something like this, which is a very common mistake. PB times BC equal to PD times DE. This over here is incorrect. This statement is not necessarily true all the time, whereas this statement above is always true. Now, if you find yourself getting confused and you can't remember this because you're always thinking of this, one way to not get confused is to look at your equation and realize that in the correct version, the same point must appear in all segments involved. So what does that mean? Well, let's take a look. In the correct version, we always have point P involved. Whereas over here, there's a P, but there's no P here, and there is no P here. Therefore, it is incorrect. So just be careful, because even though this is the correct version, it is very tempting to think of it as this. But now that all the theory is out of the way, let's get into our first problem. So, over here, AB is equal to 3, AD is equal to 4, DE is equal to 8, and we need to find the length of BC. So by power of a point, AD times AE equals AB times AC. Let's fill in what we know. So AD is 4. AE is 4 plus 8. AB is 3. And AC is equal to BC plus 3. When we divide both sides by 3, we'll get 16 equal to BC plus 3, which means that BC is equal to 13. So now let's finish this off with 2 more problems. So here are the final 2 problems for power of a point part 2. So in this first problem, AB is equal to 8, BC is 12, the length of the whole segment, AE, is 16, and we need to somehow find DE. So we can start off by writing the power of a point relationship using point A. So that would give AB times AC is equal to AD times AE. Let's fill in what we know. AB is 8. AC is going to be 8 plus 12, which is 20. AD is unknown, but we do know AE. We're given that it's 16. So then we can find AD is equal to 10. Okay, so that's AD, but that's not what we're trying to find. We want to find DE. So how can we find DE? Well, if we know the total length AE is equal to 16, then DE is just going to be equal to AE subtract AD. And 16 take away 10 gives 6. Nice and simple. Let's go on to the next problem, which says AB is equal to 10 and AD is equal to 15. And we need to somehow find CD. Okay, now it may not seem like we have much, but actually we have enough information to solve this problem. So once again, we're going to write out the power of a point relationship. So AC times AD is going to be equal to AB squared. So we're using the tangent version of the power of a point formula. Let's fill in what we know. We don't know AC. We do know AD is equal to 15 and AB is 10. So then we can find AC to be equal to 100 over 15, which is the same as 20 over 3. And once again, we're not trying to find AC, we want to find CD. And CD is just going to be AD take away AC. And 15 minus 20 over 3 is the same as 25 over 3.